So the rule of reflections is very, 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 very simple. Okay, there's only two different rules that we have to worry about. All right, reflecting across the x-axis and reflecting across the y-axis. So it's great that we only have two things to remember. The tricky part is that, well, you'll see it's a little bit kind of mixed up from what you would typically assume the case to be. So if we're reflecting across the x-axis, let's say that we have a point, we call that point A, and A is located at 3, 4. All right, when we reflect point A across the x-axis, that 3, 4 turns into 3, negative 4. So our rule here, if we wanted to write a rule for reflecting a point across the x-axis, we can say that the rule is x, negative y. X, negative y. So all we have to do is keep the numbers the same. Got a question over there? Okay. I'll move it up, don't worry. Keep the numbers the same. And then we're going to flip the sign of our y coordinate. So this is why I said that our rules today are going to be kind of backwards from what we would typically think. Right? We're flipping across the x-axis. So your brain is going to tell you, change the sign of the x-coordinate, right? You associate x-axis with x-coordinate. We actually have to do the opposite here. When we flip across the x-axis, we change the sign of our y-coordinate. That's the key thing we got to keep in mind here. Now, if we reflected point A, 3, 4, if we reflected that across the y-axis, A prime would be at negative 3, 4. Yes, sir.
What's on top of the y-axis?
Sorry, reflection across the.
City?
Yeah. There we go. There's our full notes that we've taken so far. I try and keep it as up close to the top of the board as possible. I know in the back it's harder to see as we move down. So I got to keep moving it up. So let's make sure. Anyway. So our rule for reflecting across the y-axis is negative x, y. So when we flip it across the x, we change the y. When we flip it across the y, we change the x. So we're going to once again keep the numbers the same. But we're going to flip the sign of our x coordinate. All right, let's take a look at an example of this. That's all the rules are, though. It's as simple as that. Victor?
Can I get some water?
Yeah, go ahead. So let's look at an example. Let's do example A. I'm going to move this up now, just so we can see the rules. There we go. Example A. We're going to identify, folks, not appropriate. We're going to identify the image coordinates of point Z, which is at -6, -3. When reflected across the x-axis. So, here's what we're going to do. We're going to take point Z, which is at -6, -3. When reflecting across the x-axis, what is our rule? Can someone tell me what our rule is when reflecting across the x-axis? Theo?
X, -y.
Exactly, x, -y. Our rule is x. I'm going to move this down. Our rule is x, -y. Therefore, z prime is going to be what? Well, our x coordinate is unchanged, right? Based on the rule, x is just left alone. So let's leave x alone. But then let's flip the sign of -3, right? If we were doing minus -3, those two minus signs come together and form a positive, right? So we get a +3 for our y coordinate. And there's our answer. Yes, Jocelyn. Sure. Any questions about this? How do we feel? Show of thumbs. Thumbs up, down, sideways. Just based on talking about the rule, I know you haven't had practice on your own yet, but how do we feel about understanding this rule as of right now? Okay, cool. It's really simple. All we're doing is flipping the sign. We just have to make sure we know that we're flipping the correct sign based on the correct axis, right? If we flip across the x, we change the y. If we flip across the y, we change the x, right? That's all you got to remember. That's it. Look at that. Under 10 minutes. It's definitely the fastest notes we've had.